Okay, I'd like to talk about sequences, give you a little introduction. Hopefully you have some familiarity with some of this. A sequence is a function whose domain is a set of positive integers, okay? All right, the domain, everything we enter, it's going to be all positive integers, okay? Notice, the domain is like our first term, right? X, notice it's 1, 2, 3, 4, 1, 2, 3, 4. Now your output that's your range, right? Okay? All right? So, remember what integers are. They're what? They're all your numbers on the number line, okay? But -1, -4, 1, 2, 3, 0, 5, okay? Except we just want positive integers, so we're going to 1, 2, 3, and so on, okay? Just positive integers, all right? This sequence, okay, comes from plugging in 1 over 1 is 1, plug in a 2, 1 over 2 is 1/2, and so on. So we'll get these terms, we'll get more into them later, okay? All right, we're going to write the first several terms of a sequence, okay? Notice the annotation here. See these brackets, these braces? That's for a sequence, and this is a sequence A, okay? And this is what's called a subscript n, this a sub n, and we can plug into that what? What goes in for n? Our positive integers, our domain. A sub 1, a sub 2, okay? So let's plug in 1 for n. This will be what we plug in 1 for our first term of our sequence. 1 minus 1 is 0, and 0 over anything is 0, and that would be our first term, okay? Plug in a 2, 2 minus 1 is 1, and down here is a 2 as well. You plug in 2. And so our second term, a sub 2, is going to be 1/2. This is the rule for the nth term or the general term, okay? All right? This is the rule how we get the terms for our sequence. We plug in a 1 for n for the first term, a 10 for the 10th term, and so on. Again, these braces are how we signify a sequence. Here's the general term or the general rule for the sequence or the rule for the nth term, okay? There's some vocabulary I'm throwing at you. Here's our first term. Like I said, what did we do? We plugged in 1 for n for our first term, and we got 0. We plug in 2 in the subscript, a sub 2. What do we do? Plug in 2 anywhere there's an n, and that gets us 1/2. 3 minus 1, plug in 3 here and 3 here. 3 minus 1 is 2, over 3 is 2/3. Here's our fourth. 4 minus 1 over 4. Notice we'll plug in 4 there. We're going to plug in 5 here, and that's 4/5. 5 minus 1 over 5. And finally, 6 minus 1 over 6. So we plugged in 1, all positive integers, right? 1, 2, 3, 4, 5, 6. We've got the first six terms of this sequence of numbers signified by this. A sub n equals this general rule, okay? The first 6 terms of the sequence are a sub 1 is 0, a sub 2, this is the subscript, second term, 1/2. The third term of my sequence a sub 3 is 2/3. The fourth term of my sequence A is 3/4, and so on, okay? Here's us graphing it with input output. You plugged in a 1, we got a 0. We plugged in a 2, we got 1/2. We plugged in a 3 for a sub 3, and we got 2/3. So here is the integers we plugged in for the subscripts, a sub 1, 2, 3, and here's the actual terms, the y values, 0, 1/2, 2/3, 3/4, 4/5, 5, 6. Okay, 2/3, 3/4, 4/5, 5, 6. These are actual terms. Here's your 1, we got a 0. 2, we got a 1/2. 3, I got 2/3. Okay, 4, I got 3/4. 4, 3/4, and so on. Okay? Let's see if I can enlarge this a little bit. Okay? We can use calculators, and we can plug in. I'll talk to you more about either plugging in the function and setting your table to start at 1 and go in increments of 1. We can go ahead and also use sequence mode, and it really doesn't matter either way. Okay, this way is a little, actually sometimes a little more complicated, specifying some things we'll get into later when we talk about recursive sequences. Okay, notice how this graph, we're going to talk a little bit when we plot these points. Notice this graph of the sequence, it seems to converge on a value. Notice, well, it looks like we might have a horizontal asymptote. Okay, so here's an example. We want to write down this first 6 terms of this sequence. This is sequence B, and it's going to go to the end terms. Here's our rule for the sequence inside these brackets. Notice this thing right here, a -1 to an exponent. I've got n in 2 places. That's where we plug in our domain, positive integers. Anytime I've got a -1 to an exponent, this will alternate between positive and negative. Okay, -1 to an even power is going to be a positive 1. -1 squared is positive 1. -1 to the 4th power. Okay, so when I plug in 1 here, 1 plus 1 is 2. -1 squared is positive 1. So it's positive 1 times 2. We plug in a 1 here, so positive 1 times 2 is 2. 2 is going to be my first term. Okay? Alright, I plug in 2. 2 plus 1 is 3. -1 to the 3rd power. And anytime you have -1 to an odd power, like 3, 5, 1, 7, 9, etc., it stays -1. Negative numbers to odd powers stay negative. Negative numbers to even powers are positive. So this will be -1 times 2 over 2, okay? And 2 over 2 is 1. So -1 times 1 is -1. That should be our second term right here, okay? And then as we plug in 3, b sub 3, here's our subscript. 3 plus 1 is 4. That makes this positive 1. 2 over 4 is 1/2. I'm sorry, third term. I'm sorry, my bad. Plug in 3. I had 4 on the brain. Let's do that again. 3 plus 1 is 4. That makes an even exponent. Makes -1 positive 1. Okay? And then 2 over 3 is 2/3. So 2/3 times 1 is 2/3, and so on. And that's how we get our 6 terms. And notice how it alternates. Positive, negative, positive, negative, positive, negative. Anytime you see alternating signs in a sequence, you've got this -1 to the n plus 1 as a component. Okay? And here's our graph again. Oops. Okay? Notice the first term, the second, the third, the fourth, the fifth, the sixth. See how they alternate across from being positive to negative, across the x-axis, okay? Notice how they all kind of converging on the x-axis. They're getting closer and closer because these fractions are getting smaller, okay? All right, here's another sequence, C of n, and this is kind of a step function. N is going to be even. N, the formula is basically, this sequence is going to be, sequence of the first, second, third is going to be whatever n is if n is even, and it's going to be 1 over n if n is odd. Okay? So let's take a look. Let's plug in 1. The first, remember, positive integers. Well, is 1 is not even, it's odd. So we'll plug in a 1 here. What's 1 over 1? 1. Okay? Now 2. The second term, c sub 2. 2 is an even number, so my term, we apply this rule. N is 2, and that's what we're going to have. So our second term is 2. Okay? 3. 3 is odd, so it's 1 over 3. 4 is even, so it's just what n is. Okay? 5, 1 over 5, 6, and see how it goes. 1 over 1, 2, 1 over 3, 4, 1 over 5, 6, next should be 1 over 7, and so on. Okay, this is kind of like a piecewise function. We have different rules if it's odd or even. Okay, and we graph it as so. Okay, here's my subscripts 1, 2, 3, 4, 5, 6, and here's the actual terms 1, 2, 1/3, 4, 1/5, 6, and so on. Okay, here we can determine sequences from a pattern. All right, and their actual rules. Here's the number E. And then it's e squared over 2, e cubed over 3, e4 over 4. This rule for my sequence, the general rule should be what? E to the n over n. This right here is basically, remember, anything to the 0 exponent is going to be, anything to the 0 power is 1. 1 million to the 0 power is 1, okay? This will be 1 over 3 to the n minus 1. Let's take a look at this, okay? So here's this general rule for this. Notice how nothing changes up here, but this ends up being 3 times, this is 1 over 1 times 3 is 1/3, times 3 is 1/9, times 3 is 27. Okay, let's take a look at this general rule. Sequence B has this rule. Notice 3 to the n minus 1. So for the first term, we plug in n, and what's 1 minus 1? 0. 3 to the 0 power is 1. 1 over 1 is 1. I plug in a 2 for the second term. 2 minus 1 is 1. That's 1/3. 3 to the first power, and so on. Okay? This one is 2n minus 1. Okay? Multiply 1 times 2 minus 1. I plug in a 1 here. 2 minus 1 is 1. I plug in a 2. 4 minus 1 is 3, and so on. Okay? Notice here, I'm going to skip this one, but notice we've got alternating signs. So I'm going to have a -1 to the n plus 1. Okay? Let's see what this... Okay, this is just your n squared. The sequence D sub-n is what? 1 squared, 2 squared, 3 squared, 4 squared. Notice we're going to have the alternating here. There's that alternating, -1 to the n plus 1. That'll get us the alternating signs. Positive, negative, positive, negative. Okay? All right. Here's a factorial symbol. Hopefully you remember what this is. N factorial is n times n minus 1 times n minus 2 all the way down to 3, 2, 1. Okay? So 8 factorial is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? 0 factorial. Here's a couple givens. 0 factorial equals 1. Okay? You just have to know that. 1 factorial equals 1. Okay, so remember what that factorial symbol means. 10 factorial means 10 times 9 times 8 times 7 and so on. Okay? All right, so here's 0. We plug in 0, 1, 1 factorial, and so on. Here's our n's and our n factorials. Okay? This is basically the definition. Notice how n minus 1 is basically, again, n minus 1 factorial is, times n minus 2 times n minus 3, etc. Okay. All right. Recursive formulas. I'm going to kind of leave this off. This is something real quick we'll get into later, but a recursive formula is where you have your first or a couple, 2 to 3, a minimum of 1, but maybe 2 or 3 terms given, and then the rest of the formulas are based off those terms, okay? So here I'm given on sequence S, my first term is 1. That's given. And then the rest of the terms are based off this. So I plug in, and here's where your domain needs to be, like in this case, 2 or greater. I plug in 2, and S of 2 minus 1 is, what's 2 minus 1? 1. What's my first term? 1. So 2 times 1 is 2. Okay, so S of 1 is given, and the rest is based off that. Okay, so the third term, S sub 3, I plug in a 3 for n. What's 3 minus 1 is S sub 2, the second term, which is 2. So that's 3 times 2 is 6. These are recursive formulas because it's based off a previous problem, okay? Let's plug in a 4, n sub 4. Well, S of 4 minus 1 is the third term. Well, the third term was 6, so it's 4 times 6 is 24. Notice 5 times, notice how this term here is used here, the 6 is used here, the 24 is used here. I plug in a 5, 5 times S of 5 minus 1, that's S sub 4. The fourth, S sub 4 is 24, and so on, okay? And here's finally the Fibonacci sequence. And we'll get into this where I get the first 2 terms given, okay? All right, I'm going to close it off. That's enough for today. Come up on 15 minutes in the max time. All right, hope you enjoyed this video, okay? Take care.